So this is the repetition part. The RDS is a reference designation system. PS is power supply systems. I am aware that there's a lot of not PS people here in the room. That is the beauty of the system, is that it works for everyone. So the examples, although could seemingly not relevant, will be because it is the structuring principles that we're working on, trying to harmonize the way we use it. All right? So the RDS is a digital representation. It's a structure, it's a hierarchical structure of any system, a fish. And then every component within, in a different aggregated level, is classified according to the classes that you use. And then with this framework or kind of a digital representation, you'll identify every single component. So you have the fish, you have the head and the tongue, and you put all those together and you have a tag. There are three kind of main pillars to the standard. First one is these aspects. So any object, and here comes our mascot, the cube, representing an object or a system, has a function and a structure that would make it fit into the big hole. It has a location, and it has a product. These are the three major aspects of the standard, ways of representing any system, and you'll have other aspects as well, like the type, and there are more being created as we speak, but we'll be focusing mostly on those three. I'll go back into the type aspect, and I'll mention the other ones as we go along. Now, you could look at this as the different aspects, as different ways of reaching your system. If you're looking for a person, you could use the address. You'd find that person. You could use his social security number. You could use his name, his phone number, his whatever. There's different ways of reaching it, and different system will prefer one of these. Now, the classic way of creating identifiers has always been to add a little bit of information about everything so that you know you get a lot of information, but not the full truth, but you don't get the full description. You get a part of it. And because it is our nature to want to cram more information into this tag, we are going to get creative. We are going to use the numbering system to make a type aspect out of it, or we're going to do it our own separate ways. And creativity is always non-standardized and the bane of digitalization. Also note that the different aspects, they are useful in different contexts. Right? So if you're working with the location aspect, it is ideal for a map, for a system like this, or a chart, or an overview of a plant, or whatever you're working with. While the function aspect is really, really good with process information, so P&IDs and control diagrams and whatnot. Well, the product aspect is super useful for things like assembly drawings, just going down to each single component, every screw and every bolt. And as a human, I know to go to the second floor of my building into the zone. I know to recognize the hydraulic system that I'm looking for, and I will find my component. Sure. But an AI system or any digital system will have trouble navigating these different aspects, especially because it's not always clear when you go from one to the other. And without these clear definitions, without the clean framework, you'll have issues doing this in a digital manner. So this is why the RDS says that you are not allowed, or you shouldn't. Not allowed is too strong. You shouldn't combine all these small pieces of incomplete information to create a unique ID, but you should have structures for each of the aspects, because then you could use them appropriately. You can use them for a map system or a GIS system or a BIM system to properly locate something from the top to the bottom. Same thing from the products. You can go from your whole plant or substation, and then you can navigate all the way through the product structure and get to your gasket or your bolt or your breaker. Same thing for the functional aspect. Going from top to bottom gives you a full idea of what this thing actually does. We'll go through some of these examples, and it should become more apparent how these can be used. Also, I'm going to try to push a bit on the differentiation between the product and the functional aspect, because they feel similar oftentimes, and they're being used interchangeably sometimes, which is not ideal. So now the classification, there are 3 levels of abstraction that you can use: 1-letter codes for main systems, 2-letter codes for technical systems, and 3-letter codes for components. So on top, the main systems, which are called prime systems, by the way, you'll have things like waterways, you'll have things like a unit, a power unit, or now hopefully a transformer system. Then you'll go a bit deeper, you'll have a gate, you'll have a breaker's bay, you'll have something smaller, and then your component systems, which are a motor, a button, a door, a gate, a breaker, a small breaker. The way you put them together is first you choose the aspect and you stick to that aspect. Then you choose your class, 1, 2, or 3-letter codes. And it always is descending, so 1-letter codes first, then 2, and then so on. And you pick an ID. And this is also important. The ID should be just that, just an ID, not contain any information. I'm saying all this, we have broken some of the rules, but this is, I'm putting my IEC ISO hat now. It shouldn't contain any information. Then you have your first level, and then, as I showed with the fish, you go deeper and deeper into the structure and going into more details as you put on more and more of these tags. Now there are, in this example, there are 3 levels, but you can repeat levels. This is also different from what a lot of other systems are used to, and this gives us a whole lot of flexibility, because then that means you can go as deep as you need to. Not as you can, but you can go as deep as you need to. This is important, right? It's not because you can identify every screw that you should do it. If we compare it to our old system, which has a very defined set of numbers, at some point you'll reach the end of the structure that points to this motor. But if you now want to work and look at the oil system of the motor, if it's an important motor, then you're out of luck, because there's no more room. So you need to be creative. Again, you don't want to be creative when you're working with these structures. So instead, if you use the RDS, you'll use actually even here less characters, and then you are free to then add in a temperature measurement, for instance. This means that you do not try to fit something into a set mold, because then you don't understand what it is anymore. Because you're forcing it into something, it becomes missing. But you stretch the mold to fit your system. This means that this tag doesn't exist. There are no miscellaneous classes in the RDS, nor should there be. Everything has a definition. Everything is described properly and defined properly, which is wonderful. It's wonderful for all digital applications. It means that there is not just one guy or girl or whatever it may be who knows what miscellaneous this is. You can be absolutely unambiguous, and you can standardize your tag even if it's the pressure sensor of the piston, of the motor, of the valve, of the bypass system, of the main valve of unit 1. Again, I'm not saying that you should go this deep. You can. Sometimes you need to. Sometimes you must. We want to make sure that the tags are understandable and that they live a long life. And that means that you go to the part or the understanding of the tag that is durable, which is what it is meant to do on its own. So a shovel is meant for digging. Even if you use it to save princesses, it is not a sword. It is still a shovel that is in our knight's hand. So this is what we're going to tag it as. We will let the rest of the system tell us what it actually does in the broader scope. So if we have an oil supply system to a bearing, you could say that the oil is reducing friction. So it's a friction reduction system. No. You look at it, you take the system out of its context, put it outside and look at it, and what does this thing do? It supplies liquid. It supplies oil. So that is what we'll tag it as, but it is part of a friction reduction system. And this tells us what it does, it tells us the meaning, it tells us also the context of which it's put in. Yes? Okay. Last pillar, occurrences versus objects. Now the RDS will point to an occurrence, not the object. Meaning if your building has an elevator and it has a motor, then that motor will be figured in a lot of diagrams. It's going to be in a lot of documentation and whatnot, but it should figure as the motor for the elevator. Now, when you change it out, of course, you need to change out everything that's attached to the individual motor, all the information, so its serial number, its age, everything that's connected to the object, the individual itself. But everything else remains the same. That is how you have a long life on your RDS tags, because it is constant. You're not doing anything other than changing the individual, so the MMA motor is a motor. We'll come back to a little bit of that afterwards. But this all means that there's, just to repeat, we have the different aspects. We have the 3 levels of abstraction for our classification scheme, and we have each individual, which is not the same as an occurrence, which is what the RDS refers to. Good? There's a lot of different parts in the standard. It might be confusing because it's also ever growing and has grown quite rapidly the last few years. But part 1, general rules, it seems that most of you already got now. It's fairly easy, but you can refer to it anytime. It is very broad. And there are things that part 1 will allow that you probably shouldn't do. I'll come back to that later. But it just gives the really basic general rules. If you just follow part 1, you will not be very standardized because there's a lot of leeway. And this leeway is because we are trying to support a lot of different domains. So parts 10 to 20 are for the different domains. Now I heard vehicles is being altered a little bit, but we'll get there. There's also oil and gas. And there's a lot of development. We're hoping more industries will join in the work. But then you'll have also properties, which are being created right now. It's going to come out next year, hopefully. We have relationships between two systems, because the structures that you get will give you a functional hierarchical structure or a product structure or a location. But we want to be able to define also within, from one structure to another, or even within a structure, you want to say that this power system also will supply power to this other system, which is in a completely different branch. That is being handled here. This is closely related to ontology creation, which Pia will tell us all about afterwards. So this is really meant that we had a good help from DNV, having an ontologist helping us with refining this part before we're going to propose it. Yeah. Yes, it is, because there will be no 11. It's going to be part of part 10, which it's good that you remind me. Thank you. So we were intended to create another part for grid and so for the TSOs and DSOs primarily. But since most of the systems and components that are being used also are stuff that we as power producers use, we want to try to put it in part 10 and rather expand part 10. We'll be coming back to that, and we'll talk specifically about that and Bane NOR's proposal, which is really good, and we'll toy with it tomorrow. But so a lot more on this. But what is going to happen is we're going to create a guideline. So the 101, the first one is, can you see the mouse? I point, where is the mouse? It's gone, disappeared. Okay. The 101 is a general guideline for power. So this one concerns both power producers and grid, but the 102 is intended specifically for grid and substations and whatnot. So this is, it's been replaced, part 11 has been replaced to rather the work of creating guideline. Yes, yes. And we are working on a part 103, which is specifically for hydro. And there's a bunch, well, a lot of them are coming later, but what I hear is part of that group. We're going to propose kind of a template for a power plant with all the components, typical components. We'll stop at a certain level, much like Team Wind did for windmills. Wind turbines, I'm sorry. I know you don't like that term. Yes. And more coming. Now, with all of this, there's a lot of tables, and even though we kind of are speaking the same language, we might be confused about what a suit actually means, especially if it's not, you're new to the concept. So we need to have a framework that will try to help us or guide us towards a harmonized way of using the standard, which is why you're here and why we're doing this. But in terms of specificity, as I said, part 1 just has the really general rules, and you need to be more specific. And you need to be more specific according to what you're working with. So parts 1 and 2, again, common for everyone, no matter if you're in oil and gas or power or utility or whatnot. And then you'll have parts 10 to 20 who are specific to general domains, construction works, power or manufacturing. And then we'll have these guidelines that I was talking about. And then on top of this, you probably should have your company specification, because even within all this framework and all this guidance, there are choices that you need to make, which you probably want to have standardized across your own assets. So I wanted to talk a little bit about top nodes. And so here's the transformer, the Optimus transformer, and it has a certain designation, so we know which transformer we're talking about. But in a different substation, there is the exact same transformer, which is also part of the same, or it will have the same designation. Now, how do we differentiate these? We use the top node, which gives us the context. So we know which power plant or whatever system you're working with, it belongs to, so that you get unique identifiers. Now, within the RDS world, you're not supposed to use unique, you're supposed to use unambiguous, which this is. Once you know you're looking for a transformer for unit 1 in Kvildal, you know exactly where you go. It is unambiguous. So the top node is important and useful, but if you know that you're working with documentation or you're working in a setting where there's no doubt that you are working with Kvildal, then you probably don't need it. But mostly, this is how it should be done. And it's a powerful tool. It's a very useful tool for in different situations. And a lot of us will be working with different domains. So the power plant has a power system with the generator, the turbine, the draft tube, all power-related stuff, but around it, there's a building. And the building has its own codes. The building we will be using the codes in part 12 instead of part 10. So if we want to work with, or we want to designate the fan for the ventilation system in the building, we will use construction works. But if we're talking about the generator, we'll use the power plant structure. Why? It makes things so much more complicated to use different tables. But there's a good reason. When we started working with part 10, we were faced with this problem. We have buildings, right? We have tunnels, we have roads, we have a lot of different stuff in our power plants. But everyone sitting around the table were hydro engineers, mostly, at the time. And we don't know anything about buildings. We don't know about ventilation systems or lighting or how a toilet works. So we do not want to include everything that's in part 12 and make it part 10 plus the production part. That would make it too big. It wouldn't make sense. Plus, if we're working with the building, we will probably be working with someone from the building industry, not from the power industry. So they would be used to part 12. So it was for practical concerns that we just unanimously just decided that we're not going to include part 12 components. They should stay there, and we'll just figure out a way of using both parts. So here is a wonderful use of the top node, which will tell us what library we should look into. Now we could say part 12, part 10. I could say you could do it as you want, but you need to, if there's a doubt, whether you're working with power systems or the buildings, then you need to add it to your top node so that it's not the tag makes sense, because this here doesn't make a lot of sense if you're using part 10 tables. There will be systems that you don't really know where it fits. Like the sprinkler system, It's obviously a part of the building, but it's also, maybe it should be part of the production system. And there's no issue in adding that system into both structure, into both models, if that is what you want. If not, if you only want it to appear one place, then you'll do a decision based on the design. This is a designer's choice. And we are working on creating those guidelines to help. There are some guidelines in Part 101, some rules of thumb, some ideas for how you could choose. And as long as you're consistent, then that's fine. We just don't want the RDS to be the hinder. We don't want RDS to be the one stopping you from using it as you see fit. And we are going to talk a lot more about how one object will appear in different structures. It already does, right? There's a sensor will appear in an aspect and will appear in a functional aspect, maybe more, because a sensor might have more functions than just one. And it might appear both in the PS and the CW structure. That is fine from an RDS point of view. Now, from an equipment supplier point of view, equipment manufacturer point of view, you have all these valves, and you'll start on a low level because you know you're supplying small type of valves, which is going to be components in a bigger systems one day. So obviously, you will not use the upper levels of a structure. You're not going to say that this is part of a unit because you just have your equipment, and what we are going to use it for is up to us, right? So then you would organize, you'd use the top node for something different. You would maybe use it to designate a model so that you can have a standardized structure for a specific valve model. Or you can add your company name. You can do whatever you like, and that is the main message here when regarding top nodes. It's a tool. There are no rights and wrongs in the usage of the top node. You can put whatever you want in it, just as long as it makes sense for you. And the structure follows. And we'll talk a little bit more. I'll go through some examples and show how these interact. Also the interaction between a supplier and a utility and how you'd use it in the structure. But again, so main point, no rules, use it in what fashion you like. For instance, now our power plants, so say Nora, these are individual, they will have a unique identifier as well, so GUID or whatever you want to call it, and depending on who is working with this power plant, it will probably be part of a larger superstructure. So if you go into our maintenance system, then we will organize them according to power plant groups, is what we call them. They are organized around the maintenance part. But Nora 1, figuring in the hydrological department's tools, will be part of the river systems, because they will structure them differently. So the superstructure will be different, and it will all be contained in the top node, and it would be useful to have different top nodes for the different systems, as long as we all know what at least this power plant is. And then you could use the same structure in the same way in the different systems, domains. Pipe aspect. All right, so HB is the definition of the HB class is liquid matter supply system. There are different types, and they have different uses. And in some situations, it might be very important to not use gas in, for instance, a firefighting system. That would be counterproductive. So you'd want to be very clear on what you are working with. And to do that, you would be able to use the type aspect. Now, the type aspect is different than the other ones in that it does not provide an identifier to your system. It doesn't provide the structure, doesn't identify what specific system you're working on. It does, however, identify what type of equipment class you're working with. So water, oil, fuel, whatever. These type aspects are not, for now, defined or standardized. So you could pretty much use it in any way you want. But if now I have in Alta, I have this liquid matter transport system, and I want to be clear on what aspect I'm using, I could either use a slash and the type description. And the slash is RDS or new line, right? So this means that, no, I'm sorry. Oh, no, back. This means that you could either do it that way, or you could have percentage HB as a new line underneath the system, telling you that this is the same object you're working with. The new line also points out that I'm not, now these are two different aspects, so they're not part of one reference designation, but they are concerning the same object. Because again, we don't want to deliberately just add new aspects into one string. Important. So this is where, because they're not standardized, these type libraries, here is another good use of the top node. So I could say this is the Statkraft library for PS systems, and then we have the description, so that I know to look into this and not the supplier's own type library. But they could have their own. And within the type library, within the type aspect, you can also make a hierarchy telling you that maybe this is oil and this is under pressure, for instance. Again, this is a tool. People have been using it more or less. I know OR are dependent on this type structure. They will use it to organize their maintenance, and it's really useful for templates and again, RCM, I'll come back to that later. So just quick recap of how a hydropower plant works. We have a dam that will keep the water from flowing away. We will have a trash rack that is kind of the coffee filter of the power plant. You'll have a gate system, which is very useful if you don't want all the water rushing into the power plant when you're doing work there. Creek intakes are to get water up from the mountains that are just laying there and not being useful. So we'll just funnel the water into our system. We have sand traps in the big tunnel systems because it's going to bring a lot of sediments. The sand traps are like big caves in the tunnel system where the water goes really slow, so the sediments can't fall down. New trash rack, pipe rupture valve so that we can stop the water if something happens. We'll have surge chambers, that's for dynamics in the waterway. I'm not going to go into that. We have the pressure shaft, what's commonly referred to as the penstock. A main valve, which I'm going to talk about later. The turbine, the generator, the draft tube gate, and then the outlet. This is the basics of a typical Norwegian hydropower plant. You'll have, a lot of times you'll have multiple units, but this is kind of the basic plant. So, how do we RDS this? Let's start with the top systems. Oh, we have a reservoir first. That's a supply and storage system. Then we'll have our energy transporting system. Now for us, this is water. In a thermal plant, that might be a conveyor belt for coal or something to that effect. Then we have our units, our transforming units. And although it pains me to call water wastes, but this is really what we want to do. We want to get rid of water, get it out. It's done its job, so we need to dispose of it. We need to get it out of the system. This is oftentimes the hardest part of your work. As you go into the details, it's going to become more obvious, but getting this standardized properly, especially across the different companies that have these types of equipments, is important and very useful to agree on. So this is also a big part of what is will be very useful in the part 102 for grid, when that gets along, that you can standardize and hopefully agree on a broad sense of how the top structure should look like. Then, as you've done your work with the prime systems, you go a level deeper. And then you can point out all the bigger components, like the penstock itself or the valve itself, portion components. You do this for the unit. So you'll have your generator, you'll have your shaft system with all the bearings, you'll have your main valve, your turbine, and then you can go even deeper. Within the generator, there's a rotor and the stator. And you'll just then go as deep as you need to. We tried this out for P&IDs, for piping and instrumentation diagrams. This works really well. Again, grouping in sensible parts, and then subgrouping, and then creating this hierarchical structure, which, again, the goal is to be intuitive. Meaning that if you're working on the HPU up on this level, you know that there's an oil distribution system, you know there's an oil storage system. Okay, I know where I want to go. I want to go to the oil storage system. Now these things are part of it. I want to look at the oil cooling system. Now, the oil cooling system who is down here. I know there's a pump, there's a heat exchanger, they are here. This should be intuitive. Again, as long as you have descriptions that any human can follow. And if you can follow that, then you don't really need to know the codes. Nor do you really need to know how it was organized and structured, because, again, it's supposed to be intuitive. We tried this also on, what are these calls again? Topological overviews, like for signals and for control systems. We tried them for flow, process flow diagrams. We tried it for single eye diagrams. It works for pretty much everything as far as we could see. So we have a standalone leakage monitoring system. The leakage monitoring system has 4 components. So there are 2 pressure transducers. There's a floater in the ditch here, and there's a control unit, the pink parts. And that's it. It is attached to the drainage system of the power plant, so this piping here. And so if we start with the product aspect, we want to identify the different parts, the different components. So from a monitor, from the supplier's point of view, also note that here is an example of how the structure is going to be made from the monitor's point of view, and that means that we're not starting on a prime system, a one-letter code, because it's going to be implemented in something bigger. So in the full power plant structure that we will be supplying, or we will be managing, then this a new structure is going to come as a subsystem, and it should be able to click in place as is. Meaning we, as utilities, do not need to create everything. We need to have an idea of how the top layers of our structure needs to be. But then as the suppliers come with their equipment, we can place it into the structure without really having to handle everything or create everything from ourselves. More on this later. So the monitoring system, here we have our 4 components. So there's going to be 4 parts of it. You have your control unit, we have the pressure sensors, and we have our level switch, the floater. 4 components, 4 products, makes sense. And then we'll have a look into this level switch and how it works. Because within the level switch, we'll have a lot of sub-components that may or may not be useful, but for the equipment supplier, they certainly want to have organized all this information, right? So you'll need a cover, you'll need the housing, you'll need the grating, you'll need the floating device, and you'll need the button, and you'll need the USB communication device. Now note that this class, and this is this circular housing component, it's called a pipe. It really isn't, or you could say that this is not really a pipe. So the reason why it was picked is because when you pick your class for your component, you want to look at the class definition. Closed enclosure guiding object in a circular rigid form. This fits the bill, matches. The class name is there for reference to help you out, but it's not defining what you are, what this class is all about. So follow the definitions. Sometimes as you do your modeling work, the class name will be quirky. It won't really fit the bill, but the definition does. That's what's important. No breaks for you yet? Or do you need one? Do you want one? No, good, all right. So that was the different parts. Now, for the functional aspect, let's look at the features. Now, we still have the same system. We have something, we have kind of a controlling function. We have these 3 sensors, but here we go into the details, and kind of here we have a little bit of a designer's choice. But for the designer, they had a different team working on the communication system. The communication system is important. It can have its own failures, its own problems. So it made sense to have also this communication system as a separate main part. Now, if you look at that, you will see also that the reason why we have the product aspect separate from the functional aspect is because there are different people that would be working with the different aspects. As a maintenance guy, you probably are going to be looking at the product aspect most of your time. As process control, you're going to be looking at the functional aspect most of the time. And the structures need to make sense to you. So this component, this USB communication device, is for the automation guy. It's part of the communication systems, which makes sense. And for the guy doing the assembly who's going to maybe replace these components, it's part of the flow switch, which makes sense to him or her. This is why these structures will be a little bit different, especially as you go down the structure. On the upper levels, they're going to look the same, probably, or not the same, but they're going to overlap. And then as you go into the details, because you have different intended use, they will probably look different. Again, as we look into our big power plant structure, you have your drainage system here, this H2, and your piping, and you want to attach your system to your piping, so you have your structure and you'll click it into place. And then you have the bigger picture of everything. Last week, I was at an oil and gas conference, Disc Show and Tell, and I saw a slide that was really, really interesting, which I thought I was allowed to share it with you guys. So this is, you've probably seen something similar to this as a project or the life cycle of a system. So you'll start by defining an idea, and then you'll do the design, and then your construction, and then your operation. Full life cycle. As you go through the different steps, you will be creating information, documentation, and it will stack up. And then it will change nature as you go along, and it will stack up even more, and you'll have more and more complex systems. Now, every time this stack of information comes into the hand of a new entity, you will lose a lot of information because it doesn't translate, because they don't feel it's necessary, because some reason, right? And this will happen over and over and over and over again. And you lose a lot of knowledge. This is also super time costly because some of the knowledge here, I don't know whether those arrows pop up. I'm sorry, it's not my slide. But you'll also have to do a lot of tailoring to make the data fit to your process. And you might also have to go back and do a lot of manual work. So this is very time costly. You're losing information. It increases the risk. And their idea to sort this out was to build up, and this is so model-based engineering is kind of the key word for this. So you start with a model, and then the model is going to switch hands, and it gets enriched. You don't lose any information this way, but you can structure it. And so for these initial phases, I just want to say also, the oil and gas industry, they have their own RDS sets, which they use for the functional aspect. They use a different structure for product and location because they are entrenched in it and it kind of works for them, but it's the same idea, the same concept, the same. So you'll start with a model, you'll start with the functions because they will be everlasting. Again, you always need a motor for the elevator in your building. So you can already get the idea from the get-go. And that name will never change. It will stay the same all the way. And you'll then, as you go into acquisition of equipment or you look at different products, you can add it to your system. At some point, you'll be able to add the individuals to the different occurrences, which are these round circle things. And when you then are in the end and you're doing the operation and your maintenance, you have the full set of information from the start without having lost anything. And if there are changes, you do your changes in the model and they will be reflected forever. Does it make sense? So this is really the crux of what I'm trying to tell. A thing will have, and this is kind of, you need to buy in on this. There will be different representations of one thing because there are now. Our process control structure does not look anything like our maintenance structure today. Completely different. But if we use RDS, then we'll be in classes. We'll be also familiar with how the RDS works and how it is modeled and structured, meaning someone whose task is to usually work with maintenance and the product structure will be able to understand and be able to navigate through a functional structure as they look for specific signals when they want to do an analysis of something. Something went wrong. And the RDS provide the flexibility that you need for all the different cases. Also, note that if we have time, I'm going to show a presentation made by SAP of how they're accommodating to this. They mentioned that they have two different product structures, one for the design and one for operation. It was made that way because, again, they have really different needs. To do that, RDS provides you with tools. You can do that. You can have two product aspects. One will have one minus as a prefix. The other one will have two minuses as a prefix so that you differentiate them. I'd like to try to avoid that. For us, it might be useful for an equipment supplier, though, because then they can provide one which gives us the full details down to the last screw or bolt, and then they can provide one that is for us to use, that's tailored to our needs, which could be very useful. And then you'd have, as mentioned, as a reference, you could go back to the old structure and look at if you want to navigate down to the bolts. But some general principles. And I will have said most of this already, but I'm going to remind you again that we want to make our models intuitive. That is our goal. That's why we're here. That's why we need to harmonize how we use them, and why also it does take a bit of work to actually make them, right? It can't be put together haphazardly. You need to have some guiding, you need to do it in a harmonized way. And sometimes it's going to become surprisingly difficult to make choices here, which also reflects the need for probably a company specifications, because you will make some choices which will impact how you apply your standard to your model. If you work with something for us, then our waterways are really complicated because some power plants will share reservoirs, some people will have multiple reservoirs, and there will be reservoirs who are cascading down to one main one who might just be just a small intake, but the reservoir is actually somewhere else. It's really complicated, so you need to have a good process to do this work. Again, that's why you're here. It's good, and what we're going to focus on tomorrow. I also said this before, the RDS is a digital name. I would suggest that if you tag something in the power plant, like a physical tag, a QR code or whatnot, then you would use the digital name to access the systems that contain information about the digital name, but that people will see the description, the human name, the understandable one, and this is important. Now, this could, of course, be a part of the tag of part of your digital system. It should be, so that you can maneuver to it, but and digital name, you're not supposed to require your colleagues to know the tags. The RDS is the skeleton of any information model. It does not flesh it out. It only will label different nodes, and then you need to attach information to those nodes, to those components, those systems. RDS doesn't do that. It just gives you the hierarchical structure. It just gives you the skeleton. And this is where it is super useful to be part of the ISO IEC standard family, because every ISO standard is supposed to be compliant with every other ISO standard. Same thing for IEC. Which means that RDS, being double logo standard, is intended and made to work side by side with other standards that will help you standardize the information that you want to put in. So when the RDS points to your main valve, you will be able to attach signals to it. Here you'll use the functional aspect, of course, and then you will have a fully internationally standardized signal name for the open or closed position of your main valve. There is no reason for any system, supplier, consultant to not be able to understand how this works because we're just following norms, international standards. Same thing if you want to use documentation. And we'll hear more about just this soon. I hope I fixed the slide, which was wrong. It isn't now, it shouldn't be. But this is how you can create a structure and organize your documentation and tag it properly. The reason why you tag it is not just for fun. It is to give a framework. It is to have a definition to what everything contains, all the way down from the unit description to the HDMI of the main valve. Same thing for attributes. You could use the CDD, or RDS is working on part 8, which will provide an attribute or properties classification scheme, which works pretty much the same way. You'll have a letter code that will describe exactly what property you're working with. Note also that when I go from slide to slide, we have different prefixes so that you know from the codes what you're working with. So you'll have attributes, which is square. You'll have the and sign, which is for documentation. You'll have the slash for signals. So it covers a lot of different parts. And we are, as I said, also working on failure modes and a system to help out reliability-centered maintenance.